student, myself Pankaj and I welcome you all to my YouTube channel Science Guruji. Okay, as we had discussed in our earlier video about this some information related to the light. So in this video we are just talking about the next topic of the light, that is types of mirror. So this topic is most important of the chapter light. First one is plane mirror and second one is spherical mirror. So plane mirror have the plane surface. Okay, those mirror whose surface are plane, that type of mirror are considered as a plane mirror. So mirror surface of mirror are plane. Okay, where they are used? They are used in our home too. It is also considered as a face mirror. Okay, daily you where you are seeing your face, that type of mirror or plane mirror. Okay, second one is our making of periscope. Making of periscope. Might you have heard in this class 8 this, and also kaleidoscope. So these are the use of the plane mirror. So plane mirror are those type of mirror whose surface are plane. Okay. Next one is our spherical mirror. Spherical mirror again divide into two types. Okay. Spherical mirror are divided again into two types. First one is our concave mirror. Concave mirror. And the second one is our convex mirror. Concave mirror and the convex concave mirror. So basically our concave mirror are those type of mirror which inward is curved. So a spherical mirror whose inwards are curved, that reflecting mirror is known as the concave mirror, and this is also known as a convergent mirror because it converts the light. Convergent mirror. Okay, why? Because it converts the light beam. Next one is our convex mirror. So basically convex mirror are those type of mirror whose outwards are the curved. Okay, spherical mirror whose outward surface is curved. Outward surface is curved. So that type of mirror are known as the convex mirror. So here is convex mirror are also known as a divergent mirror. Okay, these convex mirror are also known as a divergent mirror. Why? Because it diverges the light. Okay, so what we have learned in this concave mirror, which are inwardly curved, and the convex mirror which are outwardly curved. Okay, this concave mirror is also known as a convergent mirror because it converts the light, and the convex mirror are which are the surface outwardly curved, and also it is known as the divergent mirror because it diverges the coming light. Okay, of the concave and the convex. Concave mirror. So the proper definition of concave mirror is spherical mirror. Spherical mirror whose inward surface are curved. Okay, and this one also it converts the light beam. Okay, that's why it is also known as a convergent mirror. Okay, so this is our proper definition of the concave mirror. Okay, let's draw the structure to but for the better understanding. Okay, so here see here that they are inwardly. Okay, this is spherical mirror. Okay, if I draw, let's see, let's understand this imaginary. Okay, their inwardly surface are curved. As we can see here that this mirror is inwardly curved, and the light which are coming from a distance, okay, light coming from anywhere, let's see, they are after reflecting to the surface, it converge. Okay, what they are, it converge here. Let's make another one. Like this. Okay, this is a roughly diagram for a better understanding. Suppose all these lights are coming from the infinity and they are after converging, they are pointed to they are all are pointed to at the same point. Let's give me a meter P. Okay, they all lights are converged in a point P. Okay, they are coming from the infinity or from the any source, then after reflecting to the surface they are all are converged to a point. Okay, so that's why they are known as a convergent mirror. Of the convex mirror, convex mirror, convex mirror are basically spherical mirror. Okay, these are also a spherical mirror whose outward surface, outward surface are curved. Okay, whose outward surface are curved. Just see like this. Okay, their surface are curved outwardly. Okay, so this type of mirror are known as a convex mirror. These are also known as the divergent mirror. Okay, because it diverge the light beam. It diverge the light beam. Okay, let's understand with the help of diagram. Suppose this is our convex mirror. Okay. This one is our plane surface. A light, okay, suppose some kind of light coming from a source, some kind of light coming from a source, after striking to the surface, it goes back to the same medium. Okay, after striking to the surface, it goes back to the same medium but the another direction. Okay, and the image which are forming, that image are the virtual image, that are not real image. Okay, the image which are forming by the convex mirror are always the virtual image. We are looking here that the light which are coming from a source and after striking to the surface, it goes back to the same medium but the in another direction. Okay, suppose some lights are coming from a source, after striking it goes back. Okay, but they all are not equal, they all are not forming a same image. So this type of light are just diverge after the striking from the surface. Okay, after striking from the surface, they all light are diverges from the surface, and the image are forming are always virtual. It means the behind the mirror. Okay, the image which are forming here, that all are behind the mirror. Okay. Maybe by this diagram you will understand what is concave and what is convex, that is image forming by the concave and the convex mirror. Okay, before going to the image formation, let's understand the what are the components are found in spherical mirrors, like what is center of curvature, focal length, what is here pole, and what is the we can say that center of axis. Okay, so let's understand this with the help of a diagram with the proper definition. Okay, let's start with the diagram. I'll make here one diagram to understand the what is center of curvature, what is focal length, and other components. So I am taking example of a concave mirror. Okay. So let's start with the center of curvature are those points where the curvature. So center of curvature are the point by which the imaginary center are formed. Let's start with our first point, that is center of curvature. So center of curvature is basically a center point of the imaginary surface. Okay, it is a center point of imaginary surface of spherical mirror. Okay, it is denoted by the C. Okay, the center of curvature is denoted by the. Next one is our pole. So pole is basically is a midpoint of the reflecting surface. Okay, pole is a midpoint of the any reflecting surface, which is denoted by the capital P. Okay, here is one more thing, that is radius of curvature. Okay, third one you can take, that is radius of curvature. So basically radius of curvature are the point which is radius of imaginary spherical mirror. Okay, so radius of curvature is basically imaginary spherical mirror's radius. Okay, we can say that, like if this one is our mirror, then let's make it proper in proper way. Let's make this. Just to understand this. Okay, suppose it is a spherical mirror, and if we are want to know that what is the center or radius of curvature, then it is nothing but a imaginary surface or imaginary spherical radius. Okay, it is a, we can say that, for example, from here to here, this one is known as a radius of curvature. From the pole to the center of curvature is considered as a radius of curvature. Now you got my point. So the distance between the pole and the center of curvature is known as the radius of curvature. Okay, let's move to the next point, that is principal axis here. Basically principal axis are line which join the pole and the center of curvature in a parallel. Okay, thus principal axis, which is the line which joining the pole with the center of curvature. Okay, so this line is known as a principal axis. axis. Okay, so principal axis. What is principal axis here? It is a line. It is a line which join pole and center of curvature. Center of curvature. Okay, it is a line which join pole and the center of curvature. Okay, now we can start our topic, but before starting, let's understand one more thing. Okay, what that, like for the focal length, and next point, one more thing has remain, that is focal length. Focal length is a basically a line with a point, sorry, it is a basically a point where the after the reflecting from this surface, light just converge or diverge. Okay, it is a point where the light beams are gets converge or diverge. Okay, and forming a image. For the concave mirror, the focal length or the focal is always in front of it. Okay, focus, it is a point where light converge, where lights converge. Okay, for the concave mirror, if we are looking here, some if some kind of light beams coming from the infinity and after reflecting from the surface, they all lights gets converge in a point. They all lights gets converge in a point. So this point is considered as a focus. Okay, and it always in front of the mirror. Okay, for the concave mirror, the focus is always in front of the mirror, and for the convex mirror, the focus is always behind the mirror. Okay, so it is a point where light gets converged. Okay, and the length between pole and focus, length between pole and focus is known as focal length. Okay, the length between the pole and the focus is known as the focal length. Okay, you got my point? So by this we are understand all the components of the spherical mirror, like what is center of curvature here, what is principal axis, what is focus, what is focal length, and what is what is pole. Okay, so all the points we have covered. Now move to our next topic, that is the image forming by the concave and the convex mirror. These 2 points are the most important point of this chapter. Okay, why? Because all the questions are coming from these 2 things. Okay, start our next topic, that is image formation by the concave mirror. So with the help of a chart, we will understand how many types of image gets formed by the concave mirror. So image formation by concave mirror, image formation by the concave mirror. Okay, so by the help of diagram we will understand this. So firstly we will put here position of object, then position of image, and the third one is their nature. What is the nature of the image? Okay, So basically concave mirror forms 6 type of image, okay, according to the position of the. So let's start. So if any object placed at the position of infinity, okay, if any object placed at infinity or infinite, then the position of image is always at main focus, or you can denote it as a capital F, and the nature of image is real, inverted and very small. Okay, here if any object placed at the infinite, then the position of image it's formed at the main focus, and the nature of image is real, inverted and very small. Next one is our just opposite of the infinite here. Second one, that is if we put the position of, if we are taking object or placed object at the main focus, at main focus, F, then the image forming is at infinite, and again here the image forming is real, inverted, but they are very large. Okay, here are one correlation in between the first and second one, that is if object placed at infinite, then the position of image is main focus, and if we are putting again the object at the main focus, the image which is forming at the infinite, it means the just opposite of the each other. Okay, next one, if any object are placed at in between the center of curvature and the focus at C and F, okay, it means the center of curvature and the focal length, then the image forming by the object is always behind the center of curvature. Okay, so here image is forming at behind the center of curvature, and image forming is real, inverted and small. Okay, image forming is here, sorry, not this, it is large. Image forming here, that is real, inverted and large. Okay, and again if we are putting at the behind of C, means the at behind the center of curvature, then the image forming in between the between this one is between C and F, then the image forming is between the C and F. Have you got my point? They are correlate with each other. Like if we are putting object in between the C and F, then the image forming behind the C, and again if we are putting behind the C object, then the image forming in between the C and F. And here one thing, that all our image are real and inverted. Okay, real, inverted and small. Okay, the image forming here are real, inverted and small. Next one is if we are place the object at center of curvature, it means the at center of curvature if we are putting any object, then the image forming is again at the center of curvature. Okay, the image which are forming is again at the center of curvature. It means the image which are forming here is equal to the object. Okay, at center of curvature, and they are real, inverted and equal size and equal to the object. Got my point? If we are putting any object or place the object at the center of curvature, then the image forming is again at the center of curvature, and this image is always real, inverted, and the equal to the object. Last one is our, if we are placed object in between the in between the focus and pole, then the image forming is the virtual image. It means the it forming behind the mirror. Okay, the image forming here is behind the mirror. It means the nature of image here is, that is virtual, erect, and large. Okay, here image forming in between the focus and the pole is behind the mirror, and the nature of the image is virtual, erect, and the large. So by this chart we can understand how many types of image forming by the concave mirror and what are their natures. Okay, take a screenshot, then we will move to the our diagrams. Let's understand this with the help of a diagram, how the image gets formed. Okay, let's start with the first object placed at the infinite, then the image forming here, that is real, inverted, and very small. Okay, how it is? This is our focal length, this is center of curvature, this is our principal axis and pole. Okay, if any light coming from the infinite, then after striking to the surface, it bounces back and it goes from the focal length. Okay, and the image forming here is that is real, inverted, and very small. Okay, because if the objects are placed at infinite, then the image forming here is very small, we can say that. Okay, here the image is very small. Second one, if object is at the focus, then how gets image formed here? After, suppose this is my focus, this is our center of curvature. If one object placed here, a source coming from real light coming from the object, and after striking, it goes back to the same medium, and one more lights which are coming from here, and after striking, it goes back again to the same direction, but here as we can see that the image forming here are very large. The image forming by these are very large. Goes back. Okay. So real, inverted, and very large. A light object which are placed at the focus, then the light source going to, after striking to the surface, then it goes back to the same direction, but the image forming here are very large. Next third point is our, if the object is placed at between the center of curvature and the focal length, then the image forming here is behind the center of curvature, and the nature of image is real, inverted, and the large. How it is? Suppose A and B, it is the object which is placed in between the center of curvature and the focal length. After striking from the surface, the light beams goes from the focal, and one light beams are again goes directly from the focal and striking from the surface, it goes back to the same direction, and these two lines are intersecting each other at a point, and this point where the image gets formed. So here image is forming is larger than the object. Okay, here image forming by the object is larger than the object. Okay, and the nature of image is real, inverted and large. So object is placed behind the center of curvature, then the image gets formed is in between the center of curvature and the focal length. Let's understand this. Okay, here we have a reflecting surface here. This one is our P. Okay, this one is our F. This one is our C. Okay, and if any object placed here, suppose this one is A and B. A light beam goes from the object parallel to the principal axis, and after striking it coming by the focal length, and one okay, and it again goes to the same direction. The light which is coming by the center of curvature and striking from the surface, it again goes back to the same direction, and here image is forming. We can say that this one is a small image. Image gets formed here are is smaller than the object. So the nature of image is real, inverted, and they are small. Okay, is it clear? All these 4 points are maybe clear. Now we will move to the our next one, that is if the object is placed at the center of curvature, then the image forming is equal to the object. Then how it is? If the object placed at the center of curvature, then the image forming here is equal to the size of the object. Suppose here is object which is placed at the C, that is AB, and one light beams goes from the parallel to the principal axis, and after striking from the surface it crosses the focus and it goes back to the same direction, and one more light beams goes directly from the focal length, and after striking from the surface it just cross the first line beam, and the image forming here is equal to the size of the object. Okay, so here AB is object and it forms the image which is A dash B dash. So here image forming here is it, that is real, inverted, but they all are, which means the image is equal. Last one is our that if the object is placed at the in between the focal and the pole. Suppose here is an object which is placed in between the focal and the pole, that is AB, and one light beam goes parallelly from the principal axis, and after striking it goes back to the same direction at the focal length, and one more light beam as goes to the after reflecting from the surface, it goes back to the same direction and cut the center of curvature. But here is any image is not forming. The image is forming is behind the mirror. Okay, image is not forming in front of the mirror. The image which are forming here is behind the mirror. Okay, so if we are just virtually try to make a line and try to intersecting it, then here A dash and B dash gets formed behind the mirror. So here image is our virtual. Here the image which is forming here is virtual, and they are erect and they are large. Okay, so this is how this image forming by the concave mirror is completed. Okay, so let's move to the our next one, that is image forming by the convex mirror. Basically convex mirror forming only two types of image, and though both images are the virtual, erect, and they are maybe the large or they may be diminished. Okay, let's understand with the help of concave mirror are used in torch, searching light, or it also used in headlight of the vehicle to get powerful beam light. Next one, it also used at the shaving mirror. Barbers use it to see the larger face of the customer. It also uses in a dentist clinic. Dentists use it to see the large image of the teeth of the patient. Okay, and this concave mirror is also used to convert the sun rays on a point to produce the large amount of concentrated heat in a solar furnace, and this solar furnace used to make food or prepare food at the large kitchens. Okay, so these are some uses of the concave mirror. Now we will move to our next topic, that is convex mirror image formation, and afterwards we will discuss the convex mirror. Convex mirror forming two types of images. Okay, so next one our topic as image forming by convex mirror. Convex mirror. First here condition is if the object is at the infinite. Okay, if object is at infinite, okay, and the second condition is if the object is between the infinite and the pole. Second one, at between infinite and pole. So let's start with the first condition. If the object is at the infinite, then the image forming here is always virtual, erect, and the point size. Okay, so this one is our convex mirror, and convex mirror focus is always behind the mirror. Okay, so here if any light beam coming from the any source, okay, and after reflecting from the surface it gets diverged. But the image formation here is this one, at the focus or at the principal focus. So here image is forming is behind the mirror and at the principal focus, and because of the image forming behind the mirror, the nature of image is virtual. Okay, so here image nature is virtual, and this one is erect, and size of the image is point size. Okay, point size, it means the very minute or very small image gets formed here. Second condition, if the object is placed at between the infinite and the pole. Let's understand with the diagram. Suppose this is our divergent mirror. This is our divergent mirror. Focus is always behind the mirror. Okay, focus is always behind the mirror. Suppose let's make larger now. Okay, this one is our pole, and an object is placed in between the pole and infinite. Suppose here AB is the object, and after reflecting from the surface, it goes back. It goes back and diverges to the another direction. Object is placed here in between the pole and the infinite AB, that is object, and one parallel line coming from the principal axis, and after striking from the surface it goes back to the another direction. One more light beam passes from this. One more light beam again passes or striking to the surface, and this light again after striking goes back to the same direction. Goes back to the same direction, and here image gets formed is this one is our focus and this one is our center of curvature, suppose. And here image gets formed here is very small. One light beams coming parallelly from the principal axis, and after striking to the surface it goes back to the same direction, and one more light beams coming from the object, and after striking to the surface it goes back to the same direction. But here image gets formed is behind the mirror, and at the, we can say that in between the pole and the focus, and the structure or the size of the image is very small. So here nature of image is virtual, erect and small. One more light goes to this center of curvature, and one more light beam is coming to the focus. Okay, and they are intersecting from at a point, and in this point image gets formed. Okay, maybe these two conditions are clear to you. So let's move to the our uses of the convex mirror. Convex mirror are basically used in vehicle to see the rear view image of the object. If we are try to see our back view, then we use our rear view mirror. Why? Because the rear view mirror are just converts the or just covered the all the object which are present around there behind. So it gets formed the erect image, and the image which are forming that are very small. Okay, and second one, these are also used in the shops which are used as a security mirror. Some kind of thieves are try to steal some object or some kind of things from the shop, then the shop owners use big convex mirror to see or to just keep eye on their customers, so that they cannot steal their things. Okay, next our topic of the light is sign convention for reflection by the spherical mirror. So for the spherical mirror, if we are consider the sign, then we have to follow the certain rules. Okay, so what are the rule and what are the sign used here? Let's understand with the help of this diagram. Okay, here I draw a diagram of the spherical mirror where left side, it means the first things, remember the object which are placed always kept the left side, and the distance always measure according to the pole. Okay, two things are must remember. First thing, that object always kept in on a left side. Second thing, whenever we measure the distance of image or object or anything, then it will measure by the pole, and the measurement is always perpendicular to the principal axis. It means the principal axis is our x-axis. Okay, let's understand this. Here we have a object that is AB. So AB is perpendicular to the principal axis. It means it is on the y-axis of the principal axis. If we consider this line as a x-axis, then the above perpendicular line consider as a y-axis. So the object height is always considered as a positive. So for the object height we will use the sign that is positive, but the distance between the pole and the object or the object distance is always considered as a negative. Why? Because it is parallel to the principal axis. Okay. Next one, that is if we are taking or if we are considering below the perpendicular of the principal axis, sorry, below the principal axis, then the sign will which one use here, that is negative. And the sign for the left side, it means the distance from the pole to the right side object or right side any image forming, that is always considered as a positive. Okay, so let's understand this one by one. First one, what I said, that object always placed at a left side. Okay. Second one, what we have said, that all distance is parallel to the principal axis. Every distance where we which are we where whatever we are measuring here, that are always parallel to the principal axis. It means the x-axis are measured from the pole of the mirror, and the distance always measured from the pole of the mirror. Next one, distance to the left side of the pole. Distance to the left side of the pole are negative, but the distance to the right side of the pole are positive. Okay, next point is distance above the perpendicular. Distance above the perpendicular to principal axis, it means the y axis, okay, are taken as a positive, and distance below principal axis are negative. Okay, and the distance below principal axis are considered as a negative. And the next and the last one is the most important, that is focal length. Okay, here one thing remember, that focal length for the concave mirror is always at the left side, and for the convex mirror focal length always forming at the right side. So here the sign convention for the focal length of concave mirror are negative. Why? Because it is forming left side of the mirror, that's why. And focal length of the convex mirror are always taken as a positive. Why? Because the focal length for the convex mirror always forming right side of the mirror, like this. Okay, here focal length, we know that it will form left side of the mirror, and for the convex mirror it will forming right side of the mirror. That's why we will use here negative for the concave and positive for the convex. Okay, here sign, remember, this one is positive and for this one is always negative. Okay, so this one is our sign convention for the reflection by the spherical mirror. Hope you understand this. So let's move to our next point. The previously we have discussed about the sign convention. Remember this sign which are used in this mirror formula. How we will use this, we will understand by the example. But before that, let's understand the mirror formula. What is mirror formula here? Here the object distance from the pole, the distance of the object from the pole is known as a object distance, and it is denoted by the small u. So the object distance is denoted by small u, and the distance from the pole to the image forming area, or the image distance from the pole is considered as a image distance. Okay, distance from pole to the image is known as the image distance, and it is denoted by small v. Okay, it is denoted by small v. And the distance from the pole to the principal focus, distance of principal focus to the pole or pole to the principal focus is known as a focal length, sorry, focus distance, focus distance, focal distance. It is denoted by small f. And the relation between all these three, are known as a mirror formula. What are the relation here? So the relation between these three are 1 upon f is equal to 1 upon v plus 1 upon u. This is the relation between this object distance, image distance and the focal distance. Okay, and by this mirror formula we will calculate the object distance, image distance and also the focal distance of the object. How we will calculate? Let's understand with the help of one example. So here we are taking an example that an object is placed 10 cm from a convex mirror of radius of curvature 60 cm. Then find the position of image. Firstly, we have to write down what are the data given here. So the given data here is, first one, what we have given, that is our object of distance. So distance of object is written is a small u. So small u is equal to 10 centimeter. But one thing remember, that what I told in sign convention, that the first rule, the object which are placed always at the left side, and the left side of the pole, the distance between distance from the pole to the left side is always taken as a negative. So that's why the here sign we will use, that is minus 10 centimeter. Got this? Second one, radius of curvature, it means the r. R is given here, that is 60 centimeter. And what we have to find? The position of image. But before the finding the position of image, we have to find out the position of the focal length. Firstly, we have to find out the focal length here, then only we can find out the position of the image. So for the focal length, that is f is equal to 2r. Sorry, f is equal to r by 2. So by this formula we can find out the focal length. So here f is equal to 60 upon 2, and 60 upon 2 is our 30 centimeter. Let's put this on the mirror formula here. What is our formula? That is 1 upon f is equal to 1 upon v plus 1 upon u. Okay, so put the data in this formula. 1 upon f, it means the 1 upon 30 is equal to 1 upon v, we have to find out. So v is not given here. Okay, so v is as usual, and 1 upon u is 1 upon minus 10. Okay, so by this sign convention we can say that here 1 upon 30 is equal to 1 upon v minus and plus, that is minus 1 upon 10. So just transfer this 1 upon 10 over the left side. So 1 upon 30 plus 1 upon 10, that is equal to 1 upon v. So taking as a LCM, so our LCM is 30, and here that is 1 plus what we have 3, that is 4 upon 30. Okay, so 1 upon V is equal to 4 upon 30. Let's change this. I'll solving over here. Okay, so here 1 upon, so V is equal to, this will what become 30 upon 4. So by solving what we get, 4 ones are 4 and 4 sevens are 28. 4 sevens are 28. How much remain? 2 remain. So it will 4 fives are 20. It means the V is equal to 7.5 centimeter. This one is our answer. Have you got this? Let's understand once more that here what the question are asking us, that find the position of image. It means that we have to find the data for the V. It means the distance of the image here. Okay, so here what we have given, the distance of the object, that is minus 10 centimeter. Why we take minus? Because we will here question is given that for the convex mirror, and for the convex mirror or the any spherical mirror, not only for the convex mirror, any spherical mirror, the object distance is always taken in a negative. Okay, second one, what we have given, radius of curvature, it means R, and the by formula f is equal to r by 2 we can find out the focal distance. So here our focal distance is 60 upon 2, that is 30 centimeter. Okay, and one more thing. Here what the according to the mirror formula, so the mirror formula is our 1 upon f is equal to 1 upon v plus 1 upon u. So by putting the data over the mirror formula, what we get, 1 upon 30 is equal to 1 upon v plus 1 upon minus 10. Here plus and minus, this will become the minus. So 1 upon 30 is equal to 1 upon v minus 1 upon 10. Okay, got this? Next one, what we have to do? Just transfer the 1 upon 10 over the left side. So this minus will become plus. 1 upon 30 plus 1 upon 10 is equal to 1 upon v. By taking the LCM, that is 30, we can solve this, that 4 upon 30, what we get, 1 upon v is equal to 4 upon 30. Over this side, if we are just switch the 1 upon v, that is v is equal to 30 upon 4. If we reverse 1 upon v, then it will become v. So v is equal to 30 upon 4. By solving this, what we get? We get v is equal to 7.5 centimeter. Okay, so this one is our first example. You can take as many as example you want. Okay, let's move to our next topic. Next one, our topic is magnification. Magnifying glass which are found at the lab are found used by the spy or the some scientist. Okay, that magnifying glasses do the job. Next our topic is magnification. So magnification is a phenomena of the spherical mirror which the zoom in the object size. It means it increase the size of the object as compared to their actual size. Okay, for example, if you have a magnifying glass at your home, you might have seen that if we are using magnifying glass and try to look over the object, then what we found? We found that the object which are beneath the that magnifying lens, it will just zoom in the object which are below that. It means the object which are placed there, that will looks increase their size as compared to their actual size. So magnification is a phenomena where the object increases their size. Okay, so here our definition is in spherical mirror, object size seems increased increases in spherical mirror. Object size seems increases, then this phenomena this phenomenon is considered as a sorry known as magnification. Okay, in spherical mirror object size seems increases, then this phenomenon is known as a magnification, and this magnification is denoted by the small m. Magnification is denoted by small m. So m is equal to height of image upon height of object. We can also write down like this one is denoted I. It means we can write down small capital I here and capital O. So our formula is small m is equal to I upon O. By this formula we can calculate the magnification of a spherical mirror, and here unit for the magnification is diopter. Unit of magnification is diopter. Okay, unit of magnification is diopter. Let's take one example. Before the example, one more thing I want to tell you, that this magnification is also correlate with the distance of the image and distance of object. Okay, here height of image upon height of object we can also write down is as like m is equal to here distance of image upon distance of object, and we know that distance of image is denoted by, that is small v, and the distance of object is denoted by small u. So by this we can say that m is equal to v upon u. But we know that the object sign is always negative because it kept over the left side. So here we can say that m is equal to minus v upon u, or like this na, v upon u. So let's write this in a proper way. M is equal to minus v upon u. This one is our formula. Basically told us about the size of the object. How it is, let's understand this by this chart. Okay, if the magnification power of a spherical lens or mirror is equal to 1, then the height of image is equal to height of object. Okay, and if the m is less than 1, then the height of image is also less than the height of object. And if the m is greater than the 1, then the height of image is greater than height of object. Okay, have you got my point? If m is equal to 1, then height of image is equal to height of object, and if m is less than 1, then height of image is less than height of object, and if the m is greater than 1, then the height of image is greater than height of object. Okay, one more thing we have to understand, that is sign convention. Here we have to understand the sign using over the magnification, and which kind of image they are forming. Okay, let's understand this by a chart of image forming here. For example, let's say we have take the negative. If the magnification sign is negative, then the nature of image is real and inverted. Okay, or we can also say that if the image forming that is real and inverted, then the sign must use there is negative. Okay, and if the sign is positive, then the nature of image is virtual and erect. Okay, how we can use this? Let's understand this by an example. Okay, here we have one numerical question. An object placed at a distance of 12 centimeter 12 centimeter in front of a concave mirror. Okay, it form a real image 4 times larger than the object. Calculate the distance of image from the mirror. So first what we have given here, so we have given here, that is first thing, that is here our distance of a object. It means our our u is given here, that is minus 12 centimeter. Again I am repeating this, that negative sign is using because the object always kept beside the left, that's why we will use negative. Okay, next one what we have given, that is our magnification power. It means magnification, what we have given, it form a real image 4 times. It means the m is equal to 4. And which type of image forming here, that is real image. So for the real image what we have, which sign we use, that is negative. So here we are using minus 4. So by the formula, our formula is, we know that what, m is equal to minus v upon u. So m is given here, that is minus 12 centimeter, and v is we have to find out, and u is given here, that is m is minus 4 and u is minus 12. Okay, now we have to just transfer these over the next side. So minus v is equal to, this one is minus v into 12. So what we get here, we will get here 12 4s are 48. First thing, that negative and negative got cancelled. First thing we can say that negative and negative got cancelled here. So we can say that v is equal to minus 4 into 12. So v is equal to minus 48 centimeter. This one is our answer. Let's understand this once more time, that our question are asked us that distance of object placed at a distance of 12 centimeter in front of a concave mirror. Here we will not see this either it will be concave or convex. We have to see the which kind of image forming here and what is the magnification power which is given here. Okay, so next one, that it form a real image 4 times larger than the object. Calculate the distance of image from the mirror. So we have given here that is our object distance, that is minus 12 centimeter, and m the power, that is minus 4. Okay, so we know that. Okay, one more thing. Now we will discuss that last. Let's understand this again. So we know that by the formula m is equal to minus v upon u. So by putting the data over this on this formula, we will get minus 4 is equal to minus v upon minus 12. So minus and minus got cancelled. What we get? So V is equal to, and transfer this 12 over the left side. So minus 4 into 12, that is minus 48 centimeter. Okay, and friends, our next topic of light, that is refraction of light. Let's understand what is refraction of light with the help of one diagram. Okay, suppose we have two medium here. Okay, our first medium, that is our air, and our second medium is, let's suppose it will be glass. Okay, suppose it will be glass, and let's draw one normal line here. One incident ray coming from a source, after it goes from the air to the glass. Here air is our rare medium. Okay, air is our rare medium and glass is our denser medium. Okay, because their particles are denser and their particles are just little bit, we can say that, depart from each other. They are differ from each others. Okay, so here one incident ray coming from a source, after it goes to air to the glass, it change their path. After going from the air medium to the glass medium, the path of light gets changes. It means it goes bend down towards the normal, and this phenomena is considered as a refraction of light. Okay, it should have to be, let me take one, this should be goes like this, but it not goes parallel to the second medium. It just bend down from their path, and this angle, here one angle is forming. This angle is known as the refractive angle. Refractive angle. And here one angle forming, we know that this one is our incident angle. Incident angle. Okay, so this phenomena where when light changes their path or bend down from their path is known as the refraction of light. Okay, so the definition, that is, when a light goes from one medium to another medium. Here we are talking about the rare and the denser medium. Okay, in bracket you can write down rare to denser or denser to rare. Denser to rare medium. Okay, when a light goes from one medium to another medium, it changes, or it gets bent from their path. It is get bent from their path, and this phenomenon is called refraction of light. Refraction of light. Okay, in the refraction there are two cases gets formed. The first one case is when light goes from rare medium to denser medium. When light goes from the rare medium to denser medium, then the path of light bends toward bends towards the normal, bend towards the normal. And the second case here is when the light goes from light goes from denser medium to rare medium, denser medium to rare medium, rare medium, then path of light goes away, sorry, bends away from normal. Okay, here we have seen two cases when light goes from the rare medium to denser medium, then the path of light changes towards the normal, that means the bend toward the normal. And when light goes from the denser medium to rare medium, then the path of light bends away from the normal. Okay, so next one we will discuss, that is law of refraction. Okay, one more thing I forget, that is here when the light goes from the rare medium to denser medium, then the angle, okay, let me tell you one thing, that angle of incident is greater than the angle of refraction. Okay, when light goes from the rare to denser medium, then the angle of incident is greater than the angle of refraction. And here when the light goes from the denser to rare, then the here angle of incident is smaller than angle of refraction. Okay, next one we will discuss, that is law of refraction. First law is also known as a Snell's law. So Snell's law states that sine of incident angle of the sine of refractive angle is a constant for a given color and given pair of media. Okay, sine of incident angle of the sine of refractive angle is a constant for given color and given pair of media. So this one is shown by the formula, that is mu. Okay, sorry, here refractive angle, that is mu is equal to sine I upon sine R. Mu is our refractive index. Here mu is refractive indices. Okay, and refractive indices are always constant for the every medium. Okay, refractive indices are always constant for the always fixed for the every object. Okay, every mediums. So first law states that the ratio between the sine of incident and the sine of refraction remain constant. It means the if the incident angles increases, then the refracted angle is also gets increases. Okay, let's understand this Snell's law by the one diagram. Okay, suppose we have a surface, plane surface here. Let's understand this first law with the help of one example. The example is here. Let me take two medium here. M1 is our air and M2 is our, suppose any medium, or suppose this one is our glass and it one is our air. Okay, this one is our normal. When a light coming from a source, when a light coming from the source, then it goes away from the normal. Suppose this angle is our 20 degree and this angle is 40 degree. So here angle of incident, that is 20 degree, and the angle of refraction, that is 40 degree, and the ratio here, ratio that is angle I upon angle R, that is 20 upon 40. It means it one is 1 upon 2. So here our ratio is 1 upon 2. Suppose if we increase the incident angle by 5 degree, suppose we increase the angle of incident by 5 degree, okay, this one increases by 5 degree, it means this one become 25 degree. So the angle of refraction also gets increases. Yes, by this Snell's law, if the incident angle increases, then the refractive angle gets also increases. So this one gets also increases by 10 degree. This one increases by 10 degree. So 40 plus 10, it will become 50 degree. So here our new ratio and our new, for as per the new data, angle I that is 25 degree and angle R that is 50 degree. So the new ratio here is 25 upon 50. It means it will again 1 upon 2. So here as we can see that here the ratio remain constant. If we are taking the 20 upon 40, then 1 upon 2, and the new data, according to that, again the ratio becomes same. So this law states that the ratio between the sign of incident and the sign of refraction are always constant for the a specific color. Okay, every specific color and the pair of their medium. Okay. Second law states that incident ray refractive ray and normal, all these lies on same surface point, just like a law of reflection, where there we have also learned that the incident ray, reflected ray and the normal ray, all these three lies on a same point of the same surface. Okay, here the second law of refraction also states that the same, the incident ray and the refractive ray and the normal, all these lies on a same surface point. Okay, so these are the two law of refraction. Hope you understand this. नमस्कार दोस्तों, अगर आपको मेरा यह वीडियो इन्फॉर्मेटिव लगा होगा तो इसे लाइक करें, शेयर करें। अगर आप नए हैं तो इसे सब्सक्राइब जरूर करें। मैं आपको मिलता हूं एक नए वीडियो के साथ। धन्यवाद।